Yes, can you hear me? All right, welcome everyone. Welcome to the Global Azure 2023, presented by North Toronto North Toronto Cloud and DevOps User Group. Sorry, a little tongue twist. Very great to see you all here tonight. We have a full house here, expecting more people to float in during the event. Hope everyone is staying safe and healthy. So Global Azure is around the world, happening in today, tomorrow, and Saturday. Over 460 sessions around the world. We're very proud to represent Toronto. I don't think the camera can capture everyone here, so just want to do a shout out to Toronto on the count of 3. Let's shout out Toronto as loud as you can. All right, 3, 2, 1. Toronto! Awesome, great energy. All right, before we begin, I just want to welcome everyone to the group. For those who are new here, I just want to do a quick intro of myself. My name is Jack. I'm a Microsoft Azure MVP. I focus on Azure and Azure automation. I'm the president of this user group, North Toronto Cloud and DevOps User Group. And for those who are on Twitter, you can follow me at jlee_consulting and the user group at North Toronto UG. I'm also an author. These are some of the books that I've written: Cloud Analytics with Microsoft Azure, Azure for Architects, and also Azure Strategy and Implementation Guide. I put together the agenda for tonight. We have 2 great presentations for you. The first one being automating Azure infrastructure with Bicep and Terraform. This will be presented by yours truly. Followed by the second presentation, let's code a drone using ChatGPT, a very hot topic nowadays, and Azure. So this is presented by my good friend, Bruno Capuano. He's the Microsoft Senior Cloud Advocate. Say hello, Bruno. He's right at the back. And we'll do Q&A and wrap up for the evening. Now, before we begin, I want to present some of the upcoming events. The biggest event coming up is the Microsoft Build, which starts on Tuesday, May 23rd, 2023. It's a 2-day event. Simply go to build.microsoft.com to register. You can also check other upcoming events at our meetup site. That's where you did your registration, northtorontoug.com. And tonight, as you know, those who have been with our group for a long time, I'd like to give away some prizes. Thank you for coming. So tonight's grand prize is courtesy of JetBrains, one of our sponsors. One lucky winner will win one of the products shown here, 100% discount coupon. So to be eligible, simply go to the meetup site and share a positive, constructive comment regarding tonight's event, and I'll pick a winner after this event and announce it after the event. All right, on to the first presentation, automating Azure infrastructure with Bicep and Terraform. So IAC, the 3 letters, is a very popular term that you hear nowadays in our industry. IAC stands for Infrastructure as Code. IAC is how we define cloud infrastructure and resources. We define them in code format so that we could reuse this code over and over again across multiple subscriptions, multiple regions, and so forth. In this presentation, I'll go through some of the different ways that you could do IAC. But the main focus for this presentation will be Bicep and Terraform, 2 of the most popular IAC tools and framework for provisioning resources on Azure. Now, how many of you are new to Azure, like brand new, never touched Azure before? 1 or 2. So when I say resources, I'm basically referring to something concrete on Azure. So for example, SQL database is a concrete application which you can host on Azure. For websites, there's app services, so that's another Azure resource. Virtual machines, so you want to host your entire environment virtually on the cloud. Virtual machine is another resource, okay, if that makes sense. So typically, you would put together a number of resources to construe your entire environment for your business. So with IAC, the reason why we use IAC, I have 3 points explaining why we need IAC. So the first thing is it prevents drift. Drift is when you have a perfect environment for your application, but somehow people go in there manually and tweak things, tweaking the knobs, right? Like your virtual machine may be for 4 cores, someone went in there and lowered it to a 2-core. In certain circumstances, that might break your application just by tweaking. So this is called a drift. With IAC, you basically define your infrastructure using code. So this prevents drift. Anytime that you run this IAC code over your infrastructure, you're basically resetting everything back to the desired state. So if I want a recipe for 4-core VM with 8 gigs memory, if someone somehow goes into that environment, tweak it to 2-core, 4 gigs memory, now your application is no longer having the optimum resource level. Rerunning the IAC script will now reset everything back to the way that you want it. So that's a benefit. Second benefit is that the IAC can be incorporated in software development pipelines. So this is a big plus. Rather than treating your infrastructure as a separate piece versus your application, now you incorporate everything into one solution. Easy to maintain, easy to upkeep. Oops, my bad. The third reason for needing IAC is that you can store your repo along with your application code. So your IAC can be stored in the same repo where you have your application reside. So once again, go into the second point, where you keep all the solution in one single piece, rather than it's something here, something there, and when it comes to deployment, you have to search all over the places. One single solution that you can deploy all together. Any questions so far? All right, when it comes to deploying infrastructure on Azure, there are many ways that you can do it. So I will highlight some of the options that you can consider, starting with the Azure portal. Azure CLI, which stands for Command Line Interface. Azure PowerShell. ARM template, otherwise known as Azure Resource Manager template. And the two that I highlighted, Terraform and Bicep, which is the main focus of my talk today. So let's go back to the first one, Azure portal. This, for those who are new to Azure, this is the interface that you would be using if you're using Azure. So it's a graphical user interface. So question here to the audience, is Azure portal considered IAC or not IAC, and why? Someone want to take a guess? It's 50-50, right? Yes or no? Huh? Not IAC, why? Exactly. It's a graphical user interface. There's no code behind. There's no automation possibility because you have to use the mouse manually to click. Right, exactly. This is not an IAC solution. So this is there's a use case for this. Even though it's a graphical user interface, you have to use the mouse to click. Suppose I'm interested in investigating if Azure SQL Hyperscale is suitable for my solution. I have not selected it as my solution yet. So it's perfect case to just go into the portal, spend maybe 2 minutes clicking around to provision it, get it stood up, play around with it, delete it to save money afterwards, right? No harm, no foul, just use the portal. So that's a perfect use case for using Azure portal. Once you're happy with it, I've selected Azure SQL Hyperscale in our example, right, as the solution. Now you should consider upgrading how you do things, how you provision it using IAC. And we'll explain what IAC and how you can do it later on. The next option that I mentioned is Azure CLI, Command Line Interface. So I'm going to zoom in a little bit. Okay. Does anyone want to take a crack at explaining what this is? I have some comments here to help. If not, I'll go through it. Any brave volunteer want to go through this code? All right. Okay, so firstly, let me choose my pen here. Okay. Can everyone see? I zoom out. Still okay, right? All right. So firstly, I'm defining a variable to store the Azure subscription. So Azure subscription is like the big container of all the things that you can put inside. And this is also how you pay for the service, is through a subscription. You have to subscribe first. Second thing under the umbrella is a resource group, so a smaller container, followed by all the tiny resources that you have that will construct your entire environment. Okay, so in this case, I am defining a subscription, followed by the resource group name, and also the name of a managed disk. Okay, here I connect to log into Azure programmatically using the subscription ID that I provided above. Okay, so once you're authenticated, you can do many things with it, including getting the managed disk ID. So this is an existing disk, already existing resource on Azure. So I'm pulling out the information using the resource group that I have defined above. Okay, and just simply getting the information to do the next thing. And use an echo statement, which is available to kind of echo back the information that I have collected on the line above. Okay, just to make sure everything is jiving. The next thing, I'm going to have a target subscription. So here is the first chunk dealing with the source subscription. Here is the destination subscription. So I'm doing similar things, logging onto the second subscription. And finally, I'm calling this to create the disk in the destination subscription, copying the source. So in a one-sentence explanation of this whole thing here, many lines of code, is that I'm copying from the source subscription, the disk, to my destination using these Azure CLI commands. All right? So that's one way of provisioning and operating on Azure using Azure CLI. Similarly, Azure PowerShell. Syntax kind of different, but the concept is similar. So once again, I'm defining a resource group, the location, and the VM name. Okay? I'm connecting to Azure using get credential. And I'm creating a new resource group. Once again, the container to hold all the resources within. And here, a single command called new Azure VM to create a brand new VM within this resource group that I defined on this previous line. And then installing some of the extensions to wrap things up. So again, Azure PowerShell is another option of provisioning resources on Azure. Neither of which will be ideal for your IAC. Reason being is that they're not idempotent. Idempotent means, does anyone want to attempt to define what idempotent is? Okay, idempotent means a script which you can execute one time, does certain things, execute a second time, third time, no harm, no foul. It will run successfully. So suppose an example is I provision this VM here. One time, I execute it one time. If I were to run this same script a second time, what do you think is going to happen? Going to error out because my VM has been created. There's no way that I could execute the line new-AZ VM a second time. It's going to error out. So this is not idempotent. I cannot execute the same script more than once. So let me show you something that's idempotent, which is ARM template. So this is the next evolution to allow IAC to happen on Azure. This is completely native on Azure. It's connecting using the Azure REST API. In this example here, so let me just explain. Is using a schema to make sure that your code is following certain schematic requirements. The section here, parameters, is accepting an input parameter that you can supply. So in this case, I'm asking for a name of a type string. Variables is to define something that's local. I can use a local variable. But here I define hello and a string called hello world exclamation dash hi. I'm not provisioning any resources, but you could. you could stand up a VM, stand up a Azure SQL here if you define it, but here I leave it blank just for simplicity of this example. Followed by an output, which I'm outputting, as you can see from the construct here, right? Format 0 and 1. 0 refers to the first, because it's a 0 base, first variable that I'm passing in. And 1 is the second parameter that I'm passing in. And both of which are defined above. Hello refers to the local variable here. Your name refers to the parameter which I'm accepting here. So suppose I run this ARM template, pass in North Toronto Cloud and DevOps user group, all right? So the end result would be hello world, exclamation dash, hi North Toronto Cloud and DevOps user group. Make sense? All right. So as you can see, if you're a programmer, you can recognize this right away. This is JSON, right? We're mimicking some kind of language style using JSON. It's extremely verbose. I'm just doing some simple thing of outputting two strings concatenated, but it takes quite a lot of lines. So I've actually done an enterprise project for a client. The end results of my ARM template consists of several JSON files. It's over thousands of lines. Very difficult to add additional things, or if there's something you want to troubleshoot or debug, you have to go through so many lines. So this is the reason why we have Terraform and Bicep. So in my next example here, this is Terraform made by HashiCorp. I'm doing exactly the same thing as the previous example, but you can see it's a lot cleaner, right? I define my input variable, local variable, and finally the output with string interpolation, $that, refer to this and that. Agree? Like much simpler, much easier to see and debug. The next example, I'll dive into Terraform later on in more details. The next example is Bicep. So similar to Terraform, but look at the number of lines of code. Even shorter. Input parameter, param, the name of the param and the type. Local variable, var hello, and the string, the same string that I used in my previous example. And the output, string interpolation. So let's do comparison side by side. Here's the original ARM template on the left-hand side. My handwriting is very ugly. And Terraform on the right-hand side. You can see the number of lines in reduction, right? Like 27 on the left-hand side, 13. I even have a comment at the top here, right? So altogether 12 lines, minus some blank spaces in between, blank lines in between. Very short. Even better, ARM template versus Bicep, right? 1, 2, 3 versus 27 lines. And here, comparing Terraform and Bicep. So you can definitely see the advantages of using Terraform and Bicep. So let me dive into the similarities between the two. Terraform and Bicep. So both are known as domain-specific language, otherwise DSL for short. For this purpose is for deploying resources on the cloud. Some of the reasons for using things like DSL is that it provides advanced functionality. So in this case, we can do looping, we can do conditional, if then else, complex object. So not just strings, but you could put together something complex. For example, strings, numbers, numerals into one single package that you can pass from function to function. This lower barrier of entry because it's easy to read, right? The syntax is very self-explanatory, so it's easier to learn rather than JSON format for ARM, which you basically need a dictionary to just go through and understand all the code. And the concept of modules and for reuse is very important too. So you can modularize in Terraform and both Terraform and Bicep to write functional pieces that you could adopt to different solutions and reuse. Okay, so more similarities between the two. So as I mentioned before, both support modules, advanced objects. They cater to the principle of programming, right? So things like loops, true, false, things like that, everything related to programming that's allowed in Terraform and Bicep. Dependency tracking, now that's important too. In the case of an Azure database, you can't just have a database without a server. You have to deploy an Azure server and host your database. So with dependency tracking, basically when you deploy a database, you would say that, wait a minute, I don't have a server, so let me deploy the Azure server first, Azure SQL Server first, and then have the database housing inside. And similarly, between the two, both are free to use. So in the case of Bicep, it's created by Microsoft. It's open source. You can find it on GitHub, full source code. In the case of Terraform, there's a free version, and there's also a paid version for enterprise and also the Terraform Cloud for Business. In both cases, you can start off using the free version just to learn it, get up to speed. So very low barrier of entry. Okay, so now that I've talked about the similarities, let me talk about the differences. Terraform is created by HashiCorp. It's established in 2014, open source, has over 1,000 plus providers. So what's a provider? Azure would be considered a provider, a cloud provider. AWS is another provider. So there are thousands of them. Not exclusive to cloud. There are other things helping you, for example, manage your files on your servers, things like that. That could be considered a provider. Terraform is cloud agnostic. So I put that in quotes. Cloud agnostic in the sense that Terraform could be used, as I mentioned, 1,000 providers, right? So not just for cloud, but other purposes too. But I put in quotes because you cannot expect writing an Azure Terraform module to deploy an Azure VM and expect to use the same code instantaneously for AWS. That doesn't work because each cloud provider has its own schema. So you basically, if you plan to deploy a VM on AWS, you would have to come up with the AWS version of your script, your IAC script. Make sense? Okay, state file. I would consider that as somewhat of a drawback of Terraform. Anytime you deploy something to Terraform, using Terraform onto Azure, it keeps track using a state file, an external file that you store, say, on Azure storage. This file, if it's corrupted in any sense, you need to fix it. Otherwise, your next deployment will not be successful. So case in point, I successfully deployed to Azure one VM and one database. But someone manually went into Azure and manipulated, maybe deleted the database. So next time when I rerun the Terraform to, say, add another secondary database, it's going to fail because the first database is no longer in existence because of the state mismatch. There are ways to get around it. You can re-import your environment just to refresh the state file, but it's kind of inconvenient, right? You would expect it to work right away, but when you're experienced with Terraform, there are ways that you can get around it. And as mentioned before, there's a free tier and also a paid version available. Pros and cons of Terraform. So some of the points I've already mentioned earlier. The pros, it is allowing abstract advanced functionality. It's open source. The same language and principle can be used across multiple cloud providers and technology, not exclusive to cloud, as I mentioned before. You could, this is almost a safeguard. You can do a Terraform plan before you actually deploy and say, go do it. It's just to double check before actioning. So that's a plus. The cons is always lagging behind the native provider. So in this case, it's Azure. So Azure, they will create new features and services and whatnot. Terraform, on the other hand, needs to be upkept in order to support those new features. It's supported by the community, supported by enterprise who are involved. Even Microsoft is involved in upkeeping. But there's a delay between new features being introduced on Azure versus being available on Terraform right away. And as I mentioned before, state file could be an inconvenience that you have to maintain and make sure that is proper. And you have to track the Terraform versioning. So this one, I have one example. I'm working on a module to deploy Azure functions with all the guardrails. Just last year, the Azure provider, the Azure RM provider for Azure functions is only one single resource. But in the latest version, Terraform, the Azure RM Terraform provider has decided to split that into two different flavor, shall we say, Windows flavor and a Linux flavor. So what that means is that my single resource module that I created last year is no longer compatible. It's obsolete. I ended up having to write two different versions, one for Linux, one for Windows. So keeping track and upkeeping with the version is very important. And that's a con, right? Because they do introduce breaking changes every once in a while. If you're not careful, then you're behind and your things may not work with the latest. Oh, secret management is a big thing. So the state file that I mentioned earlier, suppose you have passwords, you have key vault secrets, it will echo back into the state file. Unfortunately, it's in plain text. So if someone somehow gains access to where you store your state file, can see your passwords. So that's something to watch out for. The way to safeguard that is to lock down where you store your state file. So if you're using Azure storage, make sure that the permissions and access level is exclusively to yourself or to the people who should have access, and not open wide that people can hack into. Okay? All right, so with Terraform, if you're excited to get started, it's very simple. I created a shortcut link. I'll share that in our meetup site in the comment field after this presentation. So essentially, you would need Visual Studio Code that I recommend. You could use other IDE as well. Visual Studio full-blown version also works, as well as other Notepad++ also works, right? But Visual Studio Code is great because of the next point. Visual Studio Code extensions. Some helpers like syntax highlighting, IntelliSense, and so forth, just by installing those two extensions that you see there within Visual Studio Code. And they're all free, nothing to pay for. And of course, Terraform binaries itself, just go to the link that I show here, and you can go step by step and install them and get started. Let's move on to Bicep. So Bicep is created by Microsoft. First production release was in March 2021, open source, just like Terraform. That's a real language that you can compile. What it compiles to is the ARM template that I showed you earlier, the very verbose, lengthy JSON format file. In fact, the two can interchange, transpile from one to the other. You can create your ARM template, and then later on upgrade, I would call it upgrade to Bicep. Or you can start with Bicep, and I would say downgrade, right? So quietly say downgrade to ARM template and work back and forth. Pros and cons of Bicep. Pros, fully supported by Microsoft, of course. Feature availability from day one. Oh, this is great. Compared to Terraform, where I said there's lag behind features. It's Microsoft, right? So the first day that they introduce a new feature is available instantaneously on Bicep. You can code it right away, make use of it. Excuse me. It's transparent over ARM. No state file. So the way that Bicep keeps track of everything that you've deployed is using the deployments that you have done already internally. No state files. And can use the what if parameter to check before deploying. So this is similar to the Terraform plan that I explained earlier. Again, it goes back and forth. You can decompile ARM to Bicep and vice versa. Cons. It's limited to what ARM can do. So Azure Resource Manager, what ARM can do, you can do with Bicep. But what ARM cannot do, you cannot do with Bicep. For example, Bicep is a DSL. It's not a general language, right? So don't expect to use Bicep, the language, to create a game, a Candy Crush, for your iPhone. That's not going to happen. And this is for Azure only, so no AWS or GCP support. And how to get started, similar to the Terraform how to get started, I created a shortcut link, which I'll share in our meetup site. So again, you need an IDE, so I recommend Visual Studio Code, and install the Visual Studio Code extension, which is that one, made by Microsoft. Now you can see the start, 5 stars, versus, I'll go back a couple slides. Yeah, you pay attention, right? 2.5 and 2.5. Okay, so maybe a bit biased, right? I don't know. All right. Back here. Yeah. And also you need Azure CLI and Azure PowerShell. And of course, the Bicep CLI binaries, which is all included in that link that I have there. All right, let me wrap it up. So in conclusion, Terraform versus Bicep, which one is better? What do you think my opinion is? Neither. They're both great tools. I like both, even though kind of hinting Bicep. But I actually use both a lot. I have one enterprise client where I use exclusively Terraform. They are not in the belief that ARM or Bicep is the way to go. Plus, they support GCP and AWS, 3 clouds in one, right? So basically, Terraform is the appropriate choice in this case. Where I have another client who is only using Microsoft Azure. So ARM template Bicep would be 100% acceptable in that case. Using Terraform may be an overkill, maybe not ideal in that scenario. So that covers the organizational fit. It depends on what you're trying to do, what you're trying to solve. And as the saying goes, use the right tool for the right job. And these tools are ever evolving. Great community support, new versions being released, and bug being fixed all the time. So not to worry that it's going to be obsolete. And lastly, try them out. They are free, so there's no barrier of entry. Go for it. And with that, thank you for being a great audience. My name is Jack Lee, and you can find me on Twitter at jlee_consulting. Thank you so much. Next up, we have Bruno. Bruno, do you need a couple of minutes to set up?
I am going to say we have pizza here. I don't know if you want to do a 10-minute break and eat the pizza. That's all right. So here's the pizza.
Okay.
The board smell it, the pizza. I see the faces. Let's break 10 minutes and then we get back.
Perfect, yes.
Can you see my screen, Alicia? An audio? Jack, are we good to start?
Yes.
Perfect. Hey, no problem.
Our next speaker is Bruno. Okay, wait, Bruno.
Thanks. Thanks a lot. And hello, everyone. Bruno Capano here. I need to update my title. Is here some echo? It's me? No? Let me minimize this just in case I don't have audio. So, Bruno here, and going to be a fast session today about drones, GPTs, model, ChatGPT, and Azure. So let's give it a try. And work in Microsoft. I used to be a senior cloud advocate. Now I lead an APP dev team of advocates. I need to update my slides on that. And hey, what are we going to see today? Okay, 5 minutes go. So a lot of Python. That's the code that I'm going to do. I'm going to write an SDK to a drone, and when we have the SDK, we are going to feed the SDK to a GPT model, and let's see if we can make it fly. And by the way, we are going to use ChatGPT and Azure OpenAI, because we also have a lot of GPT models in Azure, and that's the important part. That's what I want to also talk about. So, big disclaimer, as usual, sorry for the crappy demos. Do not use this in production. No, I am going to share everything later, but please do not do this at home or at work or whatever, and the bad demos, bad jokes, and everything else. So sorry about that. And a couple of people asked me what I am going to use, which is the drone that I'm going to use. I'm going to use this one. It's a super, super non-professional drone. So you are going to have fun. I like it. It's small. It's super. It's also not very expensive. I mean, when you talk about drones that you can program, you need to start to think usually on the $1,000, $2,000, usually up to $2,000 or more. This is $100, and on special sales days like Black Friday or something like this, you can even get these for $60, $75. I think I have 2 or 3 of them, and one of these was $50 because crazy day of whatever. And I like it because when you see the specs of the drone, you have a Wi-Fi connection to the drone, so you connect with your mobile or your computer or something via Wi-Fi. Depending on where you are, you can get between 5 meters to 30 or 40 meters of distance, which is kind of nice. Again, it's a toy, so the battery is it's 10 to 13 minutes. I never get over 10 minutes. I like the camera. The camera is not a very good one, but 720p is good enough to do some computer vision stuff. So I like it. But I really, really like this one when someone showed me a video of kids programming the drone. And the kids were using this programming environment, which is Scratch. Yes, it's a block-based programming language. And they were basically, they have a drone like this. This is with the skin of Iron Man. But they would say, OK, take off, flip, and then move forward, move back, land, all with this. So I like it. I like it a lot when I see the video and I say, hey, cheap drone, SDK, they have a programming language or whatever. There's probably an SDK there that we can use. So I went there and started to find the SDKs, and there is no SDK for the drone. The only thing that you can find is this is a super crappy PDF deep on the internet, deep on the DZI, on the Horizon Robotics website, that basically explains how you connect and how you work with the drone. And the idea is that once you are connected to the drone, you can open 3 ports to the drone using UDP. I don't know how many of you knows UDP, one of the worst protocols, communication protocols ever. So TCP, HTTP, TCP is amazing. You have 2 parts. The parts first then do a handshake, and then they validate how they are working together. In UDP, you have 2 parts. One part started to send message, and you wish for the best. You don't know if they arrive. You don't know. You maybe send A, B, C, and in the other side, they get C and A, and that's order. So UDP is amazing. You never know what's happened. And this is what we have here, UDP. Also, we have a third. We have 3 ports. We have 3 connections that we can open here. One is to send message to the drone, like take off, land, do some stuff. The other is to read information from the drone. Battery, the drone has an accelerometer, so we can see how when it's moving, the 3 axes of the accelerometer, the temperature of the drone, a couple of things there. And then the third port is for the camera. We can open another port. This is the 11,111, and that's for the camera. And that's super nice. So I don't know which is, this is not today, but this is very similar. So the first thing that I want to show you is something that you are going to see a lot today with me on the drone, because I need to connect to the drone. And remember, this is a toy, and it gets disconnected, it works a lot, it's not working fine, it's not a professional one, but this is how I use this. So in my connections, let me also open Zoom it. So I am going to connect to the drone via Wi-Fi. I have several Wi-Fi connectors here. Finally, in Windows 11, we can have more than 1 or 2 or 3. So I have 2 Wi-Fi that I can use here. So the main one is connected to the network here. And the second one, when I just turn the drone on, after a couple of seconds, I am going to see here a Telo drone. Let me switch back. And here, turn it on. Yes. Let me turn it on again. So I should see here a new wireless, a new Telo. Come on, appear here. Okay, this is demo mode, of course. This is how it works. Let me go back here one more time to see. It's not here, no. Go to Wi-Fi 2. Okay, there it is. So this is my drone. So this is the Wi-Fi. I am not going to use Windows to connect to the Wi-Fi, because Windows, when I connect to the drone and I check the connect and automatically connect, Windows is going to realize that the drone is not connected to the internet, so it's going to disconnect and try to connect something that makes sense. So what I am going to do, sorry about that, I am going to use the crappiest workarounds ever, which is, by the way, I need to change this, which is flight LAN, which is, let me 1 second. So I know the IP of the drone. This is my drone IP. And I am going to use a command here to basically connect using net, wireless LAN, connect, and I have the name of the network, and I have the interface, but the interface is 2. So if I do this, After a couple of seconds, as you see here in the left, yes, in the left, we are connected. So right now I am connected to the drone. I'm showing you this because every time I'm going to do a demo, I need to get back here, see if I am connected, I am disconnected, and start to see how it works. So once I am here, I am connected. Sorry, we are connected. Let's do the most boring demo ever, which is basically write some lines of code to connect to the drone and read the battery value. So that's it for a slide for me. Let me go back here and in my labs, in my drone, let's create a new folder. I'm going to do this in, so today we are 5/11. Let's go to here. This is where we are, and let's create a new one, which is a new Python file, which is going to be demo.py. Can you see is the size of the code fine? Needs to be bigger? Perfect. Like so, 3 libraries to use here. Sockets, of course, we need to open socket to connect to the drone. Time, I am going to use the most not advisable timeout pattern ever to connect to a drone and validate stuff. Sorry about this. And threading, because every time that we connect, each one of the sockets is going to be open in a new thread, so I don't block the main thread. So after that, let's give it a look of how this works. So this is the standard ABC of what we are going to do. So I'm going to have a function to receive data. I'm going to connect one of the sockets. I'm going to receive chunks of 1024 bytes. And this is going to run in a while true forever with an empty try catch. Don't do this. That's it. And it's also online. But it works for the demo. It works. But the idea is that I am going to read here. And this is the socket to read the status, to send information and to read the status. And when I say that, when I send the message, like example, take off, the only information that I may get is OK or error. But I don't know OK or error for what, or OK or error for something else. I have another one. I have another socket here, same pattern. But in this one, I receive a chunk of 256 bytes. And this is a big string that I convert, I decode from Axie8, and then here is I have a big string where I'm going to have the battery, the accelerometer, the vector of movement, the barometer, the temperature, and more information there. You're going to see this live. So this is an example here. I know after I process the info that the battery is the 1821 here. So this is the super simple information to read information from the drone. If we want to send commands to the drone, again, a similar approach here where we have I am going to create a timestamp. Then I am going to use the client socket to send a command. The command could be, this is all came from the PDF. The command could be take off, move right, move left. Everything is described there. And then I am going to wait for the response. The response is one of the variables that we checked before to see if I have something there for 5 seconds. Otherwise, I'm going to return false. Again, this is not the best way to do this, but it's simple enough to explain it here. And by the way, I do this in Python. I did this demo also in C++ and in C#. And Python is amazing because in Python with 90 lines of code, I will have this up and running. In the other languages, it will require more code. So Python is super nice to explain this. So I have the functions to send information, have the functions to read information. Now let's connect to the drone. I have my IP, I know the port. So what I am going to do, I am going to create a couple of sockets here, client socket, state socket, and that's it. We are going to see the camera later, but I love this because it's literally 2 lines of code in Python. If we want to do the same in C++, it's going to be a little longer, a little bigger. But hey, it's going to work. We have almost everything. The final thing that I need to do before writing an app is run these eternal loops to receive data and to read the state in different threads. So I have 2 threads running all the time this, and that's basically it. And they run in daemon mode, which is kind of nice because they are isolated, but I can access this. So that's it. 90 lines of code to work with the drone. So let's write an application. And this is an application that I can write. I define a battery variable here. Remember, before I assign the battery to array item 21, so this is my battery. The first command that I need to send is the string command. This is also something that I learned by not reading and then reading the PDF, because I was sending command, but when you are not in an official SDK, you need to send command, and then I will read, hey, give me the battery. Also, everything is there. Defensive programming there. Let's wait 5 seconds just in case, and then print the battery. So again, this is the most boring demo ever, but let's give it a try. So let's open another terminal, and in the meantime, let's see if I am connected. Oh, I'm still connected. That's amazing. And I know I should not be surprised that I am connected. But with the drone, you never know. So let me go to the location where I am doing this. This is the file that I just created, 7:40 p.m. So let's do Python demo.py. And if I'm still connected, which I think I am, after a couple of seconds, I will have the battery value at 80%. So that's my battery value. And again, most boring demo ever. But the first time that this was for me, I was, wow, this is amazing. I love it. So let's change something here to make it a little more interesting. So I will run this time sleep 20 seconds. And instead of getting the battery, after getting the battery, I'm also going to print in the console the list. So let's get disconnected. Demo mode. So turn it on again. It's on. There it is. Let's connect. Wait a couple of seconds. One more. And there it is. So now when I run the same, and when I run, I start to get info there. And if I start to move the drone around, you're going to see that the code is changing, the terminal is changing. I leave it there, go back to the standard. This is because we have accelerator information. And there are a couple of, I am going to review the values here, but there are a couple of very nice info that we get from the drone. So 20 seconds was too much. So let's take a look here. So first we have pitch, roll, and yaw. Then we have vectors X, Y, and Z. As far as I understand, we have an accelerometer. So we have the 3 axis that when the drone is flying, we know that it's going this direction. But we also have small memory. The drone has small memory. So I can't remember how many of these values it store, but it doesn't create the vector of flying. So even if it's flying like this and somehow it's going like this, the vector is saying, okay, you are going up. This is super useful if you want to practice and start to learn something to do anomaly detection. When you have values that doesn't make sense, you have this here. We also have temperature, Fahrenheit, low and high, time of flight. I never use it. Then we have the battery, 80%, barometer, time, I don't remember what is time, and then I have accelerometer for X, Y, and Z. So we get all of this basically with 100 lines of code, I think. Let me go to the end. Yes, 108 lines of code, which is nice, which is fine. We can do some stuff here. I can even start. I'm not going to make the drone fly right now. I'm going to wait until the end to fly the drone because that's the moment where it hits the wall or not working. Or we still need to talk a little more about this. But it's not the idea today to talk about camera. I am not going to talk about the camera, but I want to give you a 5-minute brief of the camera because this is super important. This is something that I really, really like. When I realized how easy it was to connect and write these lines of code to work with the drone, I also started to figure out, okay, how can I access the camera? And I know the address UDP, IP, port 11,111, and then I start to figure out, okay, what can I do? How can I access the camera? And I test a lot of stuff, and nothing really works until I remember that I know OpenCV, and I've been doing a lot of stuff with OpenCV. And OpenCV, let's do camera.py, and OpenCV, it's one of the most popular, if not the most popular, library to work with images. It's been, I think it was written by Intel 10, 15 years ago in C++. It's been ported to C#, JavaScript, Python. You have wrappers all around the globe. It's super, super popular. And in order to access a camera, you basically need to do a couple of steps. First, you need to connect to a video capture element. And here I am going to ask in my machine example that, hey, connect to this, I have a couple of cameras here. So the second one, which I think is the front camera, that's fine. But I can change here this, and instead of giving a number, I can do an IP address. I can say connect to this HTTP camera or RSTP camera or something else, and it's going to work. And once I have this video capture, the next thing that I need to do is basically write a loop and start to ask for, give me the last frame, give me the last frame, give me the last frame. A frame is an image, and I can start to do amazing things there. Save the image, save a video, or here what I am doing, I am going to resize this, create an image, and then show it in a window. Let's change the name of the window, like Global Azure 2023. So this is kind of a very simple demo. Let's run it so you can take an idea of how it's working. So let's do Python 05. And again, this is going to open the camera. That's me. Just work like this. Again, 45, 50 lines of code and it works. And I don't have anything here, but if I change here the front camera to the second camera, I think this is the back camera. Yes, so this is the one that I have here in the back. So here, I'm basically putting my hand here. When you have people here, it's nice to do and show your faces, but not today. And the only thing that I am doing here is if I press the letter Q, I am going to exit the loop, just in case. So let's do the same, but for the drone. So here, what I can do is drone 40. I am going to use the same lines of code. So everything that we already did in the first demo is here. The main difference is I am also doing, I am also using OpenCV, but a couple of important lines here. So after I send the first command, I need to say to the drone, stream on, open the stream. By default, the stream camera is not enabled. So if I ask this, it's going to open the camera. And then I am going to use OpenCV, as you see in line 103 and 104, basically to connect to the camera. And instead of giving the index of a local camera, I'm going to give the address. I know the address, I know the IP, I know everything. That's it. The next line of code are very similar. So 41, sorry. So here, drone 31, drone 32. I'm going fast, sorry. Drone 33. So the next lines of codes are very similar. Have the battery here. I send the command to read the battery. This is kind of a ping that I'm doing to the drone to also show how much battery I have here. And then I'm going to show the drone camera here. And let's change this and Global Azure 2023 drone. I'm sorry, I didn't show this later. The only extra step that I need to do here is 34 is once I close the application, I need to send a command which is stream off. If I don't do this, I need to take out the battery, wait a couple of seconds, 10 seconds, until it resets, because the drone gets in the very weird state. So here we are. Let me go back here. Let's see the files that I have here. I have camera and demo, and let's see if this works. Shoot down, yes, not connected. So turn it on. It's on there, and let's connect. 1 second, 2 seconds, not connected. One more time. There it is. So now I can go here and do Python camera.py. It's going to connect to the drone. It's going to open the port, send the camera. This is the bug info from from OpenCV. And after a couple of seconds, this is the drone. And if I start to move the drone around, imagine that the drone is flying. This is all of you. Sorry, I should probably ask before putting your face there. But hey, this is kind of nice. This is me. Oh my God, this is so dark. So here, here, here. So this is me. And as you can see, it's also very, very fast. I mean, the camera works great. Let's show you something cool. So an example here, I can't remember the number, so I'm going to get here. I can start to do some face detection 45. So I can do something like Python. Python. So I can Oh, I missed the models. Python 44. Python smile, face and banana, Asian gender 46. Let me see if 46 works. No, I don't have the models, but I can show you later a very simple demo to do face detection. That you can detect this, or even if I have a banana that I had but I eat it, we can do something to recognize the banana. And I can show you a couple of online demos, and you can see a couple of demos later and blogs and videos about how you can even use this to follow a face, to follow something, to detect something. That's not the idea for today. But I hope it makes sense because it's super nice to also have access the camera. So with all of this, and after we do this, we can do face detection, we can do recognition. I want to switch gears. By the way, does this make sense? Yep. Okay, because this is the part that we start to connect everything together. I want to switch gears right now and I start to talk a little about OpenAI, ChatGPT, and everything that we have. So as you probably know, we have an amazing partnership with OpenAI. And one of the cool things that we can do is that we can use the models that they are creating in Azure. And we can also give access to people who have Azure subscription to use it. And the main three activities that we can use with them, we can use the model right now, are working with languages, working with code, and working with images. So ChatGPT, an example, the published ChatGPT use a model which is GPT 3.5. It's going to be 3.5 Turbo anytime soon. GPT Plus, the one that the one that you pay, is use a GPT-4 model, the same model that we use in Bing Chat. And when I talk about ChatGPT, I usually talk about 3.5. If I talk about 4, I will say 4. Codex is a model designed and trained to work with language. This is what is in the back of GitHub Copilot. Anyone is using Copilot here right now? Perfect. You are as happy programmers, I guess, because I am super happy with Copilot. And then we have DALL-E. DALL-E is kind of amazing. DALL-E is kind of great. DALL-E do amazing things. If you want to do some DALL-E stuff, I can show you. But the key thing here is that we have these models. We have language models, programming models, and we have image models. But it's super important to understand that the key way to interact with these models is via prompts. Is how we ask stuff to the models. And there's a full discussion around how the prompts are working. There is an amazing course right now about prompt engineering. We publish a couple of Learn modules or Microsoft Docs around prompting. But let me show you how important it is to know how to prompt a model. So this is Azure. And by the way, let me change something because I am losing my eyes here. No, 200, no, 150. Okay, it's better. So Azure, I have Azure OpenAI here, which is kind of nice. Let's open here the studio. So most of the AI products in Azure and other products have what we call a studio. And a studio is kind of a playground where we can play around and see what we have. So I have here, and by the way, everything that we know, this is a service in Azure. So we are going to have the same levels of, we're going to have a super similar approach to access to these models. So, an example, we're going to have keys. If you want to store the keys and we want to do this in a secure way, I know Jack is going to say use Key Vault. I know. I put my keys in the code and commit and go for it. But everything that we know about Azure services is here. Transmission, security, keys, everything is here. The main difference is that we are working with models. We are working with AI models. So here I have created to work, I have created 2 models. A GPT 3.5 model and a GPT-2 model. GPT-2 is old. It's super old. 1.5 years. That's old for us today. Remember, ChatGPT was released November 30 last year. Not even 6 months ago, or yes, probably 6 months ago. But GPT-2 is a little older, but it's old. But I have this one because I want to show you, if we learn how to prompt stuff, how we can take advantage of the models. So I have these 2 models here, and I can go here to one of the playground, one of the spaces that we have to play around, and I will change to use my GPT-2 model. And here, let me go to my notes. I am going to ask a question. This is one question that I have here to ask. And it's a very simple question. It's a question that I don't know if you, this is going to kill me. I don't know if you read about, but these models are not very good with math. They're becoming better, but the initial models were not very good with math. And this is a simple question. We have Janet. She has a farm, and she gets 16 eggs per day, use a couple for breakfast, use another to bake muffins, and then she goes and sells the last 9, $2 each in the market. So how much money is she making? The correct answer should be 18. But when we use this model, this is a GPT-2 model. I think GPT 3.5 will answer this correct. But this is another model. When we ask this question to the model is going to give us something wrong. And even before going there, I am going to change a couple of parameters here. I'm going to change the temperature. The temperature is basically a value between 0 and 1 that defines how creative the model will be. I don't want any creativity here. Give me an answer. This is pure math. And also, probabilities is very similar to temperature. It's also related to how creative. But I want here, do not give me something crazy. Go for the right answer. So with this approach, if I ask this question, this is the response that I have from the model. So Janet make $18 per day. That's wrong. That's bad. We don't want this. This is one of the first tests that people are starting to do here, and they basically blow their mind. Okay, this is not working on whatever. But when we learn how to prompt, when we learn how to interact with these models, we can tweak a little this one here, and instead of asking the question, we can give the model some context. This is what we call in the AI world, the machine learning world, a zero-shot training, where we have a model ask a question and go for it. Or this is a few shots. Before asking the question, I'm going to give a model a couple of examples of how a human will probably resolve a problem like this. So in the first one example, we have 3 cars in the parking lot, 2 more cars arrive. How many cars are there? So we have a Q&A. We explain, okay, there are 3 cars. 2 more arrive, 3 plus 2, the answer is 5. I know, it's super silly. But it's super important to understand that the model needs this. The second question is a little bigger, it's a little longer. And Mark is getting a couple of magic cars or whatever. But in this one example, I have a typo here. This should be 1,000. I didn't write 1,000. The first time I did this demo, it was basically a typo on my side, but somehow the model was smart enough. So when he is doing the math, he realized that, hey, this should be 1,000. But he understands the question and the answer. And the last one is a little even more tricky, because I am going to give the model some context, some info, but not using numbers. I am going to use letters to describe numbers. So I'm going to talk with the unit of measure, which is going to be dollars. I'm going to say, hey, Craig has a $20 bill. And instead of doing 20, I'm going to write $20 bill. With all of this, I can ask the same question about Janet, and it's going to answer. Let's see if it works. It's going to get the right answer here. It's going to say, hey, $18 per day. This is what we were expecting. And we didn't change anything. And by the way, when I do this, a couple of people say, why don't you use GPT-4? GPT-4 is super smart. Quoting smart. Again, these models are not smart. Are super amazing, but not smart. Because it's expensive. Because here, when we use these services, we have this unit, which we call tokens, which is basically 1,000 tokens is around 700 worth or something like this. And we pay per token. And these models are cheap. Let me define cheap. In GPT 3.5, and I hope I have the numbers right, 1,000 tokens, it's 0.0002 cents. And we basically measure the tokens on when we use Azure or when we use the service, we measure the token with the info that you send and the info that is generated. So you can use, an example, 443 tokens to send, and you have 200 in back. So this is 600 tokens. You don't even get close to the 0.0002 per $1,000. GPT-4 a little more expensive. GPT-2, DaVinci 2, it's super cheap. So if I can use the cheapest one, with a little trick here to have this working, hey, I will go for the cheap one. That's for sure. And again, GPT-4 will go and solve this in the first shot. It's amazing. But it's simply going to be a little trickier. If you are planning to do something big, you're going to go and scale, learning how to prompt is super important. And by the way, here, I can also define somewhere here the max token that I want to send in the inputs, the minimum tokens. I have a couple of things that I can even do to make this a little more better. But remember, using the last model is not what we always want to do. There are options to do this. Oh, and by the way, if you need to do this again and again and again, you don't want to add the first 25 lines or whatever, the first 3 questions and answer to do this. In Azure, what you can do is you can create your custom model here, which is basically pick up a base model type. I don't have anyone here, but pick up GPT-2, add a name, and then you have training data. And in training data, you can basically upload a JSON file with questions like this, or something similar, which is basically going to give your model a context. This is not transfer learning that we do in machine learning, but it's very similar. So this is going to be a custom model that if I train a model with the same question in my initial data, it's going to be good at math. Again, good at math, for a very simple example like this. But this is all of the type of things that we can do in Azure. And that's kind of amazing if we know how to use it. So with all of this, and getting at the end, you're probably going to say, okay, how the hell this is related to programming a drone? I can do crazy things. I am going to go for ChatGPT. So let's go for ChatGPT. I can do crazy things when I understand how prompts are working. So I can go here, and by the way, this is not even plus, this is 3.5. I can go here, I can go to my, let's close this. I don't need to give the full GPT model the complete code that I am using. I just feed the model with a couple of lines that I'm going to use to fly the drone, and then start to ask things to the model. So an example, I can say, hey, use this Python code as reference. I'm going to use block here, code start, code end at the end. And then I have here display battery level, take off, flip left. I have flip left here, flip L, move the drone up 5. I also have here move the drone left 5, rotate the drone counterwise 90 drone, and then land. And I'm going to ask GPT right now to, okay, generate code to take off, flip right, move down, and I can't remember, and move down and land. So with this, I can go to ChatGPT and wish for the best. First of all, the UI have a super cool code visualizer where we know what it's going to do. And take a look at this. I didn't explain that I said flip left, flip L. It was smart enough. I don't want to say smart, but it was, it understand that, hey, maybe flip L is to go left, to flip right, flip R. The same with up. I didn't show how to go up and down, but he understand this. And then I have take off, flip right, and send, move down, and then land. I know how this drone works, and this is not going to work because UDP, because my computer is going to connect to the drone, it's going to zoop the 4 commands, and maybe we get land, whatever. So I am going to ask right now to ChatGPT to add a 5-second delay between commands. So what it's going to do right now, first of all, is import time, because it understands that, hey, I want to add a delay, and in Python, we do this with time. So the first line of code is import time, then first command, and then time sleep, 5 seconds. Second command, time sleep, 5 seconds. So I can copy this and start to use it. So let's copy this code. Let's go here to, oh, sorry. I have somewhere here my test flight here, and should I, no. And after the battery, yes, let's paste the code that was generated by ChatGPT. So take off, take off, flip right, down, and land. Let's see if this works. So this is not going to be connected right now. Turn it on. Let's clear this and go here. Does this make sense while I am connecting? That's the idea, and I know it's the most silly demo ever, but this kind of idea. So I'm connected, so let's do this. Put the drone here. Cross fingers and go for Python 04 and can't remember what we want to do. Take off, write, down, land. So once it's connected, it's going to take off. 5 seconds, it should fly, it should do a flip, down and land. It did everything. Land, land, land. Okay, it's not landing. There it is. I don't know why it didn't went great at the same time. But literally, the code was generated by ChatGPT. I can go back here and say, okay, now generate code. Generate code to take off, flip left, rotate 90 degrees, move left, and land. Let's see what it's doing. Same stuff, same stuff, same stuff. Take off, flips. Oh, perfect, there it is. Land. Copy code. I can go here, go back to my code, and from time to paste. I'm still connected. Yes. I leave it to find. Yes. So we give it a try. I can't remember what it has to do. Take off, flip left. Now it should rotate. Or no? I don't know why it's going down. So it's rotating the camera there, and it should be landing anytime soon. Probably it's going to hit the table. I don't know why landing is. Okay, there it is. But super, not easy, but we feel a very, very little piece of info here to ChatGPT, and with this was good enough to start to understand what we can do. I mean, I can ask, a couple of days ago we did the demo and someone requests something super crazy. It's not going to happen. But if we add vision here and we have a function doing vision stuff, we can even say, hey, make a plan or create code to the drone fly and navigate until find the reactor image. It's probably going to happen. So that's it. Before going to the end, if you want to learn more about drones, if you want to learn more about this, I have all of my resources. Everything here is in aka.ms/BrunoDrones, or you can start here. You are going to find there, can't remember, plenty of stuff. I need to add a couple of, there it is. I need to add a couple of lines, a couple of post about this, but you have the intro to the drone, how you can do Python, how you can connect to the drone, how you can do more stuff. Plenty of things that you can do here, and it's all here in this QR code on elbruno.ms. Yes, I know, that's a bit. So before moving forward, what we did today, SDK, write it from scratch, little understand how we can access the camera, read the telemetry, and then use GPT models. I should probably change this and add a couple of prompting. When I did the first demos, I didn't explain prompting, but I think it makes sense to talk a little about prompting because, it's super important to understand this. So we use the model to generate a flight plan, and then we wish for the best. This is kind of the idea. So that's basically it. The only final request or whatever I'm going to ask you is, this is not a service that anybody can access right now. So there is a waiting list, but I need to double check the URLs. I'm going to share it later. But you can request access here to the OpenAI models in Azure and give them a try because they are super, super powerful. You can do crazy things here with these models. And imagine this in top of a really powerful, I don't want to say a chatbot, but a suggestion system, a website, or something like this, doing translation. There are so many things that we can do with these models that I really, really think that you can give it a try. So that's basically it. I was aiming for 40 models. I'm always there. So if you want to contact me, sorry, not even this one. You can find me on Twitter, at bruno.com. You can find me on my website. I am everywhere. And hey, I hope you like it. I hope it makes sense. I hope you learn something. And thanks for joining in the Global Azure. Any question that we want to answer here, or we can chat a little later. We still have some work to do with Alexia to clean everything. But any questions? Our Samoa. I don't have idea. These guys are super freaking smart. I don't really know how they have, I mean, I have ideas of how I don't know the details, how they managed to get 200 drones flying all together, synchronizing, and also this not flying in only, I think that they also having some sensors and some connectivities, whatever, so they know that they always need to be 10 meters away one of each other. So I don't know, really, I don't know. It's amazing. It's blown my mind. This is the very basic entry level of doing things. That's level 400. This is 100. This is level 400 or even more. But hey, maybe start here. Any other question? Yes. It wasn't so long because I found a guy who started, he didn't finish to create the SDK in C++, but he gets to 50%, and then he said, that's it, I don't want to do it anymore. So I used part of this code to understand what he was trying to do, but then I switched it a lot. He tried to do in a single, once you know, I show it, it's very easy. But it took me a couple of days, a couple of nights of playing around, trying to figure out what to do. But once you know, okay, this is basically this is a Wi-Fi stuff that you can connect, send information, read it, move it up and down. It's not very complicated. That said, if you want to say something like he mentioned, when you have several drones and you have a lot of connections open and try to synchronize everything, that's a completely different story. I don't even know how to start. It's probably a nice challenge, but I don't have time to do it. Yes?
Maybe the drone activate the camera so they can shoot
Oh, yes.
at the same time.
Yes, I don't want to make the drones. Okay, let me show you a cool demo. By the way, for the online people, I think we are good, Alexia? Because we are entering the demo is not going to work soon, so I don't want to be online. So let me show you something. We are connected. Oh, we are not connected. Oh, yes, we are connected. So let me show you this one. So this demo.